how to substitute, how to use greatest common factor. All these things are important in this lesson. All this together with the canons that they have given you that you have to remember. Is that clear? So now, if we cannot read, if we forget how to add fractions, if we forget how to add like terms, if we forget how to do GCF, this is where we will be crying more. Okay? So those are the things I noticed as I was going through the examples. Okay. So we have basic trigonometry identities, okay? So we have to ask ourselves, what is that? An identity is an equation where the left side is equal to the right side. X is equal to X. 5 is equal to 5. A squared is equal to A squared. So when the left is the same as the right, we are going to call that an identity. Okay. Now, and it has to be true for all values. All values. Not for some, for all. Okay. If you're testing or if you're checking, you have to say "sir" for all of them. Okay. That is when you become an identity. Okay. And you are defined. All right. Now, you have two equations over here. You have this. You have two su'als. You have this su'al and you have this su'al. So they're asking you, who between these two is an identity? This will be more of an identity than this because sine cannot be the same as cos. To me, this cannot be an identity. Yes? But this is an equation. I can make this equal to this and then solve, and I should be able to. How do I solve this? I have x squared minus 9 over x minus 3 equals to x plus 3. I want to remove this denominator. What should I do? I will multiply both sides by the denominator. I'll multiply this side by x minus 3, and I'll multiply this side with x minus 3. This x minus 3 will cancel because taksim becomes this, taksim this will become 1. So this will be x squared. Is that my laptop dying? No, my laptop is charged. Okay, x squared minus 9. And then if I use, but I should know that this should give me this. You should know that. But if you forget, you do distributive property or you do FOIL, whichever way. If you do distributive property, this becomes x minus 3, and this becomes plus 3, x minus 3. And then this becomes x squared minus 3x plus 3x minus 9, because you're going to do distributive property. So, like that. Okay? And then this becomes 0. So then this becomes x squared minus 9. Identity because the left is the same as the right. Okay? So that is what an identity function or an identity, what is it called? Yes, an identity function means the left and the right must be equal the same. Now, in trigonometry identities, what are they? They are identities that involve trigonometry functions. When I see trigonometry, I am thinking of sine, cos, tan, cotangent, cosine. What is the other one? Cosecant, secant, and cosecant. Yes? So these are the things that I am thinking about that when I see the word trigonometry. Okay. Now, trigonometry identities are identities that involve trigonometry functions. You already know a few basic trigonometry identities. The reciprocal and the quotient identities below follow directly from the definitions of the 6 trigonometry functions that you're learning in this lesson. Okay? How do I write sine? 1 over cosecant. How do I write cos? 1 over secant. How do I write tan? 1 over cotangent. How do I write tan? Sine over cos. So there is different ways. So here you have reciprocal, here you have quotient. Okay? All right. You can use these basic trig identities to find trig values. Trig identities, you will use them to find trig values. As with any fraction, now here you have to think about fractions. The denominator cannot equal to 0. Okay? All right, so let's look at question A. You have been told use the reciprocal and the quotient identities. To do what? To find sine theta. Who do you know? I know cosecant. I want to find sine theta using cosecant. I go to my Kanun and I write sine theta is the same as 1 over cosecant theta. These people who are coming late are disturbing us now. They should come on time. So we stop going back and forth. Okay. So now, do I know cosecant? Yes. How do I know? From here. The Sual gave it to me. I will put here 1. I can write it different ways. I like writing it like that. 1 taksim cosecant theta. On my calculator, wahed taksim 7 over 4. Sir, what do we do when we do taksim with fraction? Keep, change, flip. We learned this in grade 3 and 4 and whatever. So this will be 1 darb 4 over 7. This will give me 4 over 7. I don't need to use my calculator. I remember my kanuns from grade 3 to now. Sual, sual, sual. Sual. Hello?
That's why we didn't put. Oh, خلاص, no سؤال.
Okay. Wadum, Mariam, sual.
No, okay, خلاص, I understand.
Okay. All right. Now we want to do this, sir. Who do I want? Cos. Who do I know? Sine. Who do I know? Cot. Already the Su'al told you what to use. The Su'al has told you what to use. So, what do you know? You know that cot of an angle will always be cos of that angle taksim sine of that angle. What do you have in your Su'al? Cot 2 over the square root of 5. What else do you know? You don't know cos x, so that will stay there, cos x. What do you know? You know sine x. Before I go there, wait, let me just do it this way. Then I will replace my rakams at one time. So, according to my su'al, I know cot and I know sine. I want this. I don't know this. So how do I remove? I want cos. How do I remove sine x? I will darb both sides by sine x. So I will do here sine x, darb sine x. This and this goes, and I want this. So I will write here cos x equals cot x darb sine x. I go to my su'al. Come cot x 2 over the square root of 5. Darb darb square root of 5 over talata. What do we do when we have fractions? If you are the same down and the same up, you go away. What is your answer? 2 over 3. Kalas. No calculator, no nothing. Su'al. Su'al.
No.
No. Okay. Let us do 1A. Who is doing 1A for us? Give me 1 second. I don't know who is at my door. Who is doing 1A? Read, think, tell me. Okay, even me, I still have one. Next week. Yes, I will. Thank you. Who is doing 1A?
Miss,
Me.
I want you to try. Okay,
Okay,
Rina.
try,
Okay, لا
try.
عادي.
Try.
Seka is 1 over cos. ده
Okay.
قانون.
Second, where is it? Yes, okay. Second, okay. You are using shui. Why is my pen not writing? Okay. You're using this, okay. Second equals to second of theta or x, it doesn't matter, equals to 1 over cos of theta. Continue.
I will multiply cos theta both sides.
Okay. Okay. Or
I will directly put it.
you will say
Put the number.
cos, you will flip. Cos
Yes.
theta equals to second, 1 over second, sir? Because you
No,
change places, sir? This will go here and this will go here.
it will not be cos times cos, then cos this one will go. Then it will be second and cos.
Let's do it the way you want. I was just thinking you can see it clearly, but we will do it the way you want. Okay, so here you have second theta over cos theta. What did you say you want to do?
Times cos, both sides.
Times cos both sides, okay.
Then
What do you
it will
have?
be, it will be second times cos equal 1.
Yes, second times cos equals 1. Who do you want?
I want cos.
Okay, so who do you move?
Divide second.
Okay, so that's what I was just telling you. You just flip because it has 1. You didn't have to do all this, but it is okay. If this is what you know, this is what you do. Divide both sides by second. I agree with you. So cos equals
1
1
over
over
second.
second. Now, what do you know? How else can you write 1 over second? I don't want fraction now. How else can you write 1 over second?
1 divide second.
Very good. So you're going to write here 1. What is it? Cos, yes?
Yes.
Cos equals 1 divide second.
Then
What do you
1
know?
divide 5 over 3.
5 over 3. Remind me, grade 3, what did we say in grade?
Keep, change, flip.
Yes, keep, change, flip. Continue.
1 multiply 3 over 5.
Very good.
3 over 5.
3 over 5 is your answer to question 1A. Is that clear?
Yes.
Who's doing 1B? I don't have space, so I will be writing over here. So that because I want you to see, this kanun should be in your brain. Is that clear? Our answer is coming from the kanun and our rules that we have been learning since grade 3. I continue. How do I do this one for 1B? What do I want?
We want tan B.
We want tan. And what do we know?
Cosecant and second.
How is tan and cosecant and secant related?
Sine over cos. No.
How is tan, secant, and cosecant related? How are they related?
Miss, we will put first that cosecant is 1 over sine and second is 1 over cosine.
Okay.
We will flip it and you will have tan sine over cosine. صح?
Okay, so now, okay, very good thinking. So you will do each one separately and then we will see. All right, so we know that cosecant is who?
1 over sine.
1 over sine. Very good. And we know that secant is who?
1 over cosine.
1 over cosine. Very good. And how do I find tan?
We will flip them, but I don't know how we will flip them.
Okay, so what's the opposite of cosecant? Sine inverse. Sir? Am I right? Cosecant is sine. Is the inverse or is the opposite? Let me think. I want to use this. I want to use this. I want to think about, is it inverse? Yes, inverse, because this is a fraction. So you're inversing. No, what is the inverse? And what is opposite? Yes, inverse. I agree, inverse. Okay. So how will I find tan? Kanun for tan is what?
Sine over cos.
cosine.
Very good. Sine over cos. Now, how will I find sine? I will bring cos down. I will take sine here. Do we understand? When it is written like this, sine equals 1 over cosecant. Right here. Do you see? Do you see this? Do you see this?
Yes.
Okay. And then I want cos, yes? Cos will be, you take cos here, you take cos on this side, you bring secant here. So cos will be what? 1 over secant. Are we together up to there?
Yes.
Okay. Now I want to taksim who? Sine, taksim, cos. We together up to there?
Yes.
How do I write sine?
1 over cosec.
1 over cosecant. I don't have space. Okay, where will I write? Let me write it over here, okay? Write it over here. Okay, so sine is 1 over cosecant, yes? And I am taksiming with who? Cos, sir? And cos is who? 1 over secant. Up to here, we are good?
Yes.
Kanun, we learned in grade 3 and 4. For dividing fractions, Kanun for
Keep,
dividing
change,
fractions.
flip.
Keep, change, flip. So we will keep 1 over CSC. We will
Multiply
darb by sec
secant.
over 1, sir. And this will go, sir.
Yes.
And now we will have what? Sec over cosec. Up to here, we are good?
Yes.
And what does this mean?
Divide.
Divide. We are dividing sec, divide, cosec. Now, do I know my sec?
Yes.
Do I know my sec? What is it?
25 over 24.
25 over, is green a good color? Let me use red. 25 over 24, divide. What's our cosec?
25 over 7.
Divide 25 over 7. Kanun?
Keep, change, flip.
Very good. Keep, change, flip. So 25 over 24, darb 7 over 25. This goes away. What is our answer?
7 over 24.
7 over 24. And we box it. Okay?
Okay.
Up to here, we are good?
Yes.
Yes.
Okay, we can move on?
Yes.
Okay.
Miss, can you see if Bashir is she's waiting?
Oh, Basha is waiting? Can I make you admin? Let me see. because I cannot, oh no, the wizard said we cannot make student admin. Okay. Good morning, Bishu. Okay. All right, so we're here now. Trig functions can be defined on a unit circle. Okay? This is what we call a unit circle. You learned this in physics. You also learned this in math. I don't remember teaching you this in grade 10. Grade 11 general have this thing. Grade 11 general are the ones who have this, but they have it in term 3. They don't have it in term 1 or 2. Okay, trigonometry functions can be defined on a unit circle as shown. Notice that for any angle, sine and cosine are the directed lengths. So the length, the height, and the base of the right triangle. So, and what did we say when we hear this word right triangle? Pythagorean. Okay? All right. So now, sorry. So this, the horizontal and the vertical length are called legs. Yes, in the right triangle, they're called legs of the right triangle. And the hypotenuse is the diagonal line will always be 1, always. Okay? Then we can apply the Pythagorean theorem to the right triangle to establish another basic trig. So here is the kanun. Okay? When you have right triangle. Sine squared plus cos squared equals wahed squared. This is kanun called the Pythagorean identity. And there are 3 of them. There they are. You should know all of them. All of them. You should know. Okay? Can we move on?
Yes.
Okay. Notice the shorthand notation. So if I don't want to write it long, abbreviate it. Shorthand just means to make it small, as in I abbreviate. Used to represent powers. Like if you see the word trigonometry, if I want to write it in short, I just write trig. That's what shorthand means, okay? So notice the shorthand notation used to represent the powers of trig functions. So sine squared is just sine angle squared. You have to use parentheses, okay? Remember, sine squared is sine of the angle and you square this. If you write it like this, sine, you're only squaring this. No, you lazima square the sine and the angle. Okay? Mushkil. This is what is correct. All right. We continue. So, if now, how will you know that you need to use the Pythagorean identities? How will you know?
They will give us 2 things to find, yani sine and cosine.
Oh, okay. Yes, they'll give you 2 things to find. I totally agree with you. So when they give you 2 things to find, you will use Pythagorean theorem. Okay, and what are those 2 things? Either one of them. Yes, sine and cos. And remember, sine and cos goes together. Tan and sec go together. Cotan and cosecant will go together. Okay, and remember, here you're adding 1. Here they should equal to 1 after you have added. Okay, these ones look the same. This is the one that is not the same. Is that clear? All right. So now I have tan and I need to find these people. I will use which kanun? This kanun, because I have tan. Do we understand? So tan theta squared plus wahed should equal to sec theta squared. Who is my tan? -8. Why should I put it in parentheses? Because theta should not be negative, sir. So you want a positive rakam. You will square this, which will give you 64 plus 1, which should give you sec squared theta. Up to here, we are good? Up to here, we are good?
Yes.
Yes, yes.
Okay. Then, what did we say? The square root of a rakam. I want sec theta now. I should square root both sides, sir. A rakam has how many roots when you're squaring? When you're square rooting it?
2 or 4?
Two. Two. A positive and a? Hello. Square
A
root of,
positive and a negative.
yes, the square root of 64 is either 8 or -8. Why? Because 8 times 8 is 64, and -8 times -8 is also 64. So the square root of a positive rakam will always have two roots, a positive and a negative root. That's why we write it over here, plus or minus, okay? Now, why do I need to find square root? Because I just want sec theta by itself, okay? So, and sec theta can be written how? 1 over cos theta. How do I know? Over here, sir, in my identities, in these canoons over here, okay? I have to remember, these canoons should be in my brain. All right, so we are here, sir. Let us see. So we're gonna do what? Square root of 65 plus or minus equals to 1 over cos theta. I want cos theta, sir. I will take this here and I will bring this, or do butterfly method. If this method is not easy for you, just put here Wahed, sir, and you will do this butterfly method like this. So here you will have cos theta times plus or minus square root 65 equals to 1 times 1. You want cos theta, you will divide by plus or minus square root of 65 plus or minus square root of 65. This goes away. Cos theta equals to 1 over plus or minus the square root of 65. So that means cos theta is either 1 over negative square root of 65 or 1 over square root of 65. Okay. Now, what did we say in math? Square root cannot be where?
Denominator.
In the denominator. So to remove the square root from the denominator, what do? You darb square root 65, square root 65. Or you put it in your calculator, it will do it for you. But you should know why it is doing that. Kanun says we cannot have square root at the bottom. Okay? So now what is your answer? Square root of 65. A square root that times a square root is the radicand. So that's 65. But it should be negative because you have negative here, or 65 square root over 65. So this is your answer. Of course. Are we together? Are we together?
Yes, yes.
Okay, then now you want to find sine. You know the canon for tan is sine over cos, sir? Yes?
Yes.
Yes,
I
yes.
put it over 1, do butterfly method, you will have cos darb tan equals to sine darb 1. Sir? Yes or no?
Yes, yes.
Okay. sine darb 1 is just sine, and that's what you want. How are you going to get it? You're going to multiply cos. You have two coses, so you're going to do it. You're going to do this 2 times, okay? One with the negative and one with the positive. So you'll have 2 answers, or. So you're going to do cos when it is negative. So put negative here. So you do square root of 65 over 65 times negative 8. Yes? And then you're going to do when it is positive, you're going to have square root of 65 over 65 darb negative 8. Sa? Yes, no, la, yes, yes.
Yes, yes, okay.
All right, continue. This will give you a positive answer, which will be 8 square root of 65 over 65. This will give you a negative answer, negative 8 square root of 65 over 65. Does this give you an error if you put it in the calculator?
No, it's just like this.
Okay, it doesn't give you an error, yes? Okay, but we need which
Yes.
answer?
The positive one?
Positive one.
Yes, you need the positive answer. Why? Because angle should be positive, sir?
Yes.
Yes, like that. Halas. And that's how you answer that one. Any question?
No.
You've understood?
Yes.
Okay. Don't forget Kanun. We go to the next example?
Yes.
Okay. You will
Miss,
do
you will
2.
not solve 2A?
I'm asking you, do you want us to solve or do you want us
Yes,
to go
only 2A.
only to A? Can I erase this? Or you take screenshot before I erase?
Okay, you can erase it now.
Okay. Okay. Talk to me. What do we do?
First, we will use cot square x
Mhm.
plus 1 equal cosecant square because we have cot.
Okay. Cot squared plus wahed equals to cosecant squared. Okay.
Now I can put in the cot negative 3 square
Okay. Negative 3 squared. So,
plus 1 equal cosecant square.
okay. Continue.
9 plus 1, 10.
Okay. Cosecant squared. Uh-huh. Uh-huh.
Now square it.
Square root both sides. Yes?
Yes.
Okay. Mm-hmm.
Now we will have cosecant theta equal square root 10.
Mm-hmm. Plus or minus square root 10 cosecant. Only cosecant, not cos. Yes, like this. Uh-huh.
Now we
Continue.
want to get tan.
Okay. Now we want to get tan. We already found cosecant, sir.
Yes.
This is our first answer. Yes. Now we want to get tan. Continue.
Sine over cosine.
We don't have sine and cosine in our work. We have cot and we have cosecant. How do I get this? We did it over here, sir. Somewhere here. Where did I see it? Here. Where is it? Tan equals secant. Sir? Remember here?
Miss, where?
Here. Sir?
Oh, okay.
Am I right? I am
It's
right.
tan equal 1 over cot.
Yes, tan equals 1 over cot. You want us to, we can use that, but we don't know cot. So we have to find cot. Oh, we know cot. Yes, okay. We know cot. Yes. We know cot. Cot is over here. Tan equals
1 over cot
1 over cot.
times cot both sides.
Why?
That's
And I want tan.
Yes, it's okay. We can keep it like
Oh, 1 divide cot.
Yes, -3, sir.
Yes.
But why I have a feeling we are not doing it correctly. I don't think we can do it this way. Lazim we do this, sir. And using cosecant and using the cot. That's what we want to do. And oh, look here, there was this also kanun. Cos has to be greater than 0. Even here, remember? That's why we were using the positive rakam. Sir, you remember in the first, I asked you, how do you know which one to use? Because Sual
Yes.
told you. Sir, I think we should find, okay, continue.
First,
Let's see.
we should we find first sine and then cosine, then we will put it at tan?
No.
Like the one we did it before.
We should use cosecant and cotan to get tan. That's what I'm thinking. But even this is correct. We know that tan is 1 over cot. Sir, we know that. So why are we making our life so difficult? Our life should not be difficult. Then what should I do? I go back to my kanun, sir?
Yes.
Why we don't use this kanun? We can use this kanun, sir? Cot squared.
But they want tan.
Oh, they want tan. Oh, we use this one here.
But
we don't know. How do we
find
second? How do we find second?
1 over cosine.
And another way? Is there another way to find?
No.
Second?
No.
You're sure? What did the swal give us? It gave us cosecant and it gave us cotangent. I mean, we found cosecant and we found cotangent. And we want to find tan, yes? What does ChatGPT say? Ask ChatGPT, how do I find tan when I know cosecant and cotangent? That's the su'al we want.
How do I find what?
How do I find tan when I know cotan and cosecant?
Miss, this is correct. Tan theta equal 1 over -3.
Okay.
Hassan, you finished.
Kalas?
Yes.
Because we want tan, right? But we were told not to use. Cos has to be greater. Okay, so tan can be negative, I guess, in this soal. Yes.
But in ChatGPT he used tan theta equals sine over cosine. He first found sine, and then he found cosine, and then he did this all.
But still the answer. But our answer is still the correct. Yes.
Yes.
Okay. We went the short way. Yes.
Yes. Here it's also cos
and then why
theta
did we
less
do all
than
this?
0.
Why did we do all this? Kev, we could have just done this.
We should find first cosecant.
Why? We didn't use it
Because he
anyway.
asked us, Miss, he asked
Oh,
us for
because he asked
cosecant
us for
and tan.
cosecant
Yes.
and tan. Ah.
Yes.
Oh,
Miss,
okay.
also they say that cosine theta less than 0.
Okay.
At the example, it was greater than 0. Here, less than 0.
The answer here should be for cos theta. But we did use cos theta anyway. So we don't care about that. Do you understand? Hello? Did you understand?
Yes.
Yes.
Yes. We don't have cos theta, cos anywhere in our work. Here is our answer. Here is our answer. Class. Okay?
There is a way to check.
Yes. Kanun. Where is Kanun? Here. Where is Kanun for cot and cos? Here, cos, here. Use this to check. Sir? We have, where is cotan? Here, sir? And we already calculated our cosecant. Yes? Did you understand or no?
Yes.
Yes. So this should equal this. Yes or no? Or over here. Look. This is -3 squared, sir, plus 1, which is equal to who?
10.
How much is this? 10. So we're correct, sir?
Yes.
10 equals to 10. Yes?
Yes.
Okay. All right. We move on?
Yes.
Okay. All right. Another set of basic trig identities involve cofunctions. Girls are supposed to go somewhere in the next 10 minutes. Okay. We will do up to here. We can meet in the evening if we don't finish in time, because you have 6 examples in this lesson. Okay. Another set of basic trig identities involve cofunctions. Okay. Cofunctions. A trig function f is a cofunction if another trigonometric function is equal to it. Okay. When A and B are complementary angles. What is complementary angles?
90.
They must add up to 90 degrees. Okay. So if your two thetas are complementary angles, so if I write here 16, I should write here 30. If I write here 41, what should I write here?
49.
49? Yes, 49. Yes. If I write here 20, I should write here 70. So if your two angles are complementary angles, so the function of the first angle, alpha, and the function of the second angle, beta, must equal each other according to this canon. Okay? Now, in the right triangle shown, angles alpha and beta are complementary. Why? Because we know the 3 angles in a right triangle must add up to 90. If this is 90, these two must also be 90 when you add them. Okay, using the right triangle ratios, you can show the following statements are true. Sine of alpha equals cos of beta, and cos of beta equals 90 minus alpha, or you can use this. So how can you find sine of alpha? Y minus R. How do I know? You remember SOHCAHTOA? You remember
Yes.
SOHCAHTOA? SOHCAHTOA. Sine equals opposite over hypotenuse. Cos equals adjacent over hypotenuse. Tan equals opposite over adjacent. Sir?
Yes.
We learned this. So that's where all these canons are coming from. Okay? If I want to find sine of alpha, I want the opposite, which is who? Y. Do you see that? And I want the hypotenuse, which is who? R. See? Sine over, opposite over hypotenuse. If I want tan of alpha, opposite over adjacent. Opposite is who? Y. Who is adjacent? X. Do you see that? So, how many ways can you find sine alpha? You can either do cos of beta to give you sine alpha. You can also do cos 90 nagas alpha. It will give you sine alpha. You can also do y taksim r. So how many different ways? How many different
3.
ways? The last. Okay, very good. So the same thing. If you want to find tan, you use cot 90 minus alpha, or you use opposite minus adjacent. If you want to find secant, you will use cosecant 90 minus alpha, all this. Okay? So those are what we are calling cofunction of the trig functions. All right. Now, you have a lot of them here also. So it depends on how the su'al will come. If the su'al gives you only this secant and cosecant, you will do this. If the su'al gives you the triangle like this, if the su'al gives you the triangle, you'll do socator. So, it's up to you. It's it's not up to you. It's up to how the su'al comes. Now, let's look at example 3. It says use cofunctions and odd and even identities to solve. Okay. Now, what did the su'al give you? The tan. And it is asking you to find the cot. So you come here and you say, I want to find the cot. And how will I find the cot of this? How will I find the cot of this? I will do cot times -1 of the angle. But you'll do the opposite. You're removing this negative outside. You're taking this negative outside. If you're taking this negative outside, this is theta, not 0. Please don't make it 0. This is theta. So what it's asking you to do the inverse. So you'll take this negative outside. If you put the negative outside here, this theta has to be negative. Okay? And this will become positive for the su'al to stay the same. Are we together?
Why did you multiply by -1?
Why? Because I know where is this canon. Where is this canon I want? I have tan, sir? Tan and cot go together, sir?
Yes.
Yes, yes. Okay. And I want to make this inside, look like this inside. Right now, they're not looking like that. So I want to switch places, sir? I want this to go here and I want this to go here, yes?
Yes.
Now, because this is negative, I don't want it to be negative, I want it to be positive. So I will take this negative outside, yes?
Okay.
Okay. If I take the negative outside, I have to switch places, sir?
Yes.
That's what I did.
Okay.
If I do distributive property, this will come back to this. Okay? -1 times pi over 2 becomes -pi over 2. -1 times negative theta becomes theta. In math, we start with positive. Positive minus pi theta, which is the same as this. Up to here, we are good?
Yes.
Okay. Right. So, cot theta minus pi over 2. I want it to be cot with the negative outside. So if I remove the negative outside, I start with the person who was negative pi over 2, and then I will minus. Why? Because a negative times a negative needs to bring me back to the positive. A negative times a positive needs to bring me back to the negative. Okay? Then, now, instead of this does not look like good math. Ishara must come first. Cot pi theta minus theta. I mean pi over 2 minus theta. Okay? Now, who is this? This is tan. You see this person? So this is negative tan theta. Up to there, we are good because it is here. See? Yes? These persons are friends.
Miss, wait, from where the negative you got it? From the negative one?
Yes, from the negative one. Oh, you want me to put the negative one here? I will. Okay. The reason why we don't write negative one is because in math we don't write the one. Yes.
Yes, but why you only multiply the one that's inside the bracket, not quote.
No. Rim, how do I write this correctly in math? The negative must come in front. It is ishara and then your items. Sir?
Yes.
It's like this, Rim. A times negative 1 times B times C. I will write negative A, B, C. Sir?
Oh, okay.
Yes, that's what I'm doing. Okay, now, Su'al gave me this, sir? Sir?
Yes.
Okay, so I just replace it. Negative 1.28. And this is my answer. Who's doing 3? Who is doing 3? Papa. Come on, who is doing 3?
Me.
Okay.
Okay,
Try.
first we will use the first قانون sine equal cosine over theta 2 minus theta.
Equals cos. Continue.
Now, we know that cosine bracket theta. Mom, this is equal to sine theta.
This does not match this. You need to make it match. So who will
okay,
you
you
move?
said correct. Math is positive and then negative.
I agree, but you need to make it look like this. This person has to go here and this person has to come here. It has to look exactly like this. Nafsi twins. So what will you do?
I will bring the minus sign outside.
Minus sign outside.
Now I will write
Cos.
Theta.
Cos.
Cos, yes.
Uh-huh.
Theta minus.
Yes, theta minus pi
over 2.
Okay. Gives you the sign. Continue.
Now we know that cosine over theta minus pi over 2 is equal to sine, negative sign.
This part equals to negative sign.
Now we have the sign, which is equal to negative 0.37. But it will be now positive.
Why do I write yes? I know.
Negative,
here I should write cos. Yes? Here I should write cos, not sin, sir.
No, صح sign.
No, cos. See?
Miss, here in the قانون sine equal cosine.
Here. You write both of them. Yes, you write the one you know from the kanun. No, you write the one you know from the question and the one you know from the kanun. Sir?
Okay.
And then you make the one from the question to look like the one in the kanun. Okay?
Okay.
I continue.
Now negative, so the answer will be 0.37, positive 0.37.
Yes, because this is negative of sine, sir. So this will be negative 0.37, 0.37. Are we together?
Yes.
Reem.
Yes.
We are good? Okay. Right. Can we meet later? We do 4, 5, and 6?
Yes, okay.
Okay, you'll
Yes.
tell me on WhatsApp. Okay?
Which time you are free?
No, you I I'm coming back at 2. I have class from 2 to 5. Anytime after 5.
ريم بعد
Okay.
بعد
بعد
التراويح.
تراويح.
Okay.
Okay.
Okay,
Thank
my
you,
dears?
Miss.
Okay.
Okay. Bye.
I practice what we have done in your you have examples over there. Yes, practice example 1, 2, and 3, and then if you have su'al, when we come back we start there. Okay, my dears?
Okay.
All right.
Okay. Thank you.
You're welcome, Mama.